Hello and welcome to my channel. I am Ensan Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and you've not subscribed to my channel, please kindly hit the subscription button for me to build my mathematics community. Now, in this lesson, we are going to look at the derivative of the natural exponential function e. Now, if x is any real number, then e to the power x equal to y if and only if the natural log of y equal to x, that is ln of y equal to x. Why? You see that if you write log x to the base 10, let's say log y rather to the base 10 equal to x. If you replace the 10 by e, that is log y to the base e equal to x. Since you have written base e, we give it another name called the natural logarithm, written as ln, that is, and pronounced as ln. So ln n y equal to x. So it means that ln n, not ln ny, ln y equal to x. So here, if I write ln y equal to x, it means log y base e equal to x. So the natural log means log to the base e. And here, from the definition of logarithm, it says that the logarithm of any number, say y to the base e, is the power to which the base must be raised to give the number. So the base e must be raised to the power x to give the number y. And that is what we have here. So here e is a number. If you have the calculator, point e, and then you see that it is 2.71828. I've approximated it to 1, 2, 3, 4, 5 to 5 decimal places. So if, for example, you take e to the power, let's say n, and you get a number k, you can take e to the power 3, e to the power 4, e to the power 5, since you have the calculator with you. And the answer that you get, if you take the natural log of the k, it should give you the exponent that we took, m. That is what we mean here. Now, how do we differentiate the natural exponential function? Now we are going to differentiate this implicitly with respect to x. Watch my video on implicit differentiation and differentiation of the natural logarithmic function from the description, or you can request for that at the comment section and I'll give you the link. So here we are going to differentiate this implicitly with respect to x. So we do this one, dd ln y respect to x, and then ddx with respect to x. Now if we differentiate ln of y, we are going to get 1 divided by y. And since we are differentiating it implicitly with respect to x, we will multiply dy on dx. And if you differentiate x with respect to x, we get 1. So here the derivative of y with respect to x is equal to 1 divided by y. It's equal to y. Why is it y? Because here we will multiply 2 by y. So if you multiply here by y and multiply here by y, this y will cancel this y. 1 times y is y. So here the derivative of y with respect to x is equal to y. And what is y? Y is equal to e to the power x. And what is the y here? That is e to the power x. So here the derivative of e to the power x with respect to x is the same e to the power x. Now what about if we take x to be a function? So if we have e to the power, let's say g of x equal to y, then it means that we're going to have ln y equal to g of x. And now if you differentiate this, we are going to have 1 divided by y, dy on dx to be equal to g prime of x. G prime of x means you have differentiated g, or it can be written as d gen of x with respect to x. That means you differentiate this and it is the same symbol. If you watch my video on basic differentiation, you get to know the symbols. So here we are going to have dy on dx to be equal to g prime of x times y. And what is y? Y is equal to e to the power gen of x. So here the derivative of y with respect to x will give us g prime of x times e to the power gen of x. And what is the y here? That is then the e to the power gen of x on dx is equal to g prime of x times e to the power gen of x. Very simple as that. So now, in simple terms, whenever you are differentiating the natural exponential function, you take the power, you differentiate it, and you multiply it by the original function. So let's start. I have plenty of examples here. So the first one, we are going to start with y equal to e to the power 2x. So what do? The derivative of y with respect to x is equal to, here our gen of x is 2x. So we take the derivative of gen of x, that is 2x, and multiply it by the original function e to the power 2x. And if you differentiate 2x with respect to x, we are going to get 2 e to the power 2x as the derivative of y with respect to x. That is what we have here. Yes, that is mathematics. Let us continue. Now, if I take y is equal to the same e to the power 2x, we can use the chain rule to arrive at the same answer. Now, how do we use the chain rule? Here, we will let u equal to 2x. Wow. And then this implies that y is equal to e to the power u. Here, the derivative of u with respect to x is equal to 2. And the derivative of y with respect to u is equal to the same e to the power u, which is the same as e to the power 2x, since u equal to 2x. Now, the derivative of y with respect to x is equal to du dx, that is 2, times dy du, that is e to the power 2x. So, whatever you pass, you get there. Because mathematics question, it has more what entry points and then more exit points. Now let's clean this and continue. Now the next example is that if I have y is equal to e to the power x cube. So what do? We have the derivative of y with respect to x is equal to, we will take the x cube and differentiate it to get 3x squared and multiply by the original function e to the power x cube. Very simple as that. That is what we have here. We take g of x, we differentiate it and multiply it by the original function. Or we can let this equal to u and go through the chain rule procedure. These are just the beginning. So let's start with more difficult ones. Now, if I have y equal to 1 divided by e to the power 4x cubed. Now this is the same as y equal to e to the power negative 4x cubed. So here, the derivative of y with respect to x will be, we take the top function, that is g of x, and differentiate, have minus 12x squared times e to the power minus 4x cubed. And this one is the same as minus 12x squared divided by e to the power 4x cubed. Very simple as that. Wow. Now, let's continue. Now, this is the same as taking this one, differentiating it and putting it at the top here. But if we do that, the negative sign will not come. So be careful with that. Now, the next example is we have y equal to e to the power the square root of 3x squared minus 1. Wow. So now let's do this one. This one I want to do it step by step. So let's go through the chain rule. So we take u equal to the square root of 3x squared minus 1. Here u equal to 3x squared minus 1 to the power half. And here the derivative of u with respect to x will give us, we multiply this by half times, we differentiate the inner one to get 6x squared, then times the original function inside, that is 3x squared minus 1, then subtract 1 from the half to get negative 1 out of 2. That is 3x squared times 3x squared minus 1, so 1 out of 2. And this is the same as 3x squared divided by 3x squared minus 1 to the power half, and that is 3x squared divided by 3x squared minus 1 under square roots. So that is our du on dx. Now, here this implies that y is equal to e to the power u, and dy on du is the same e to the power u. Or if we differentiate e to the power x, we get the same e to the power x. If we differentiate e to the power u, we get the same e to the power u. And what is u? This u is square root of 3x squared minus 1. So let's do that one here. It means that I need part of the board. So you go. So here we are going to have dy on du to go to e to the power square root of 3x squared minus 1. So here dy on dx will be du ds, that is 3x squared divided by square root of 3x squared minus 1 times e to the power square root of 3x squared minus 1. And this will give us 3x squared e to the power square root of 3x squared minus 1, all divided by square root of 3x squared minus 1 as our final answer. Wow! Now, let's take another example. Let's take another example. If we have f of x to be equal to e to the power x divided by x squared minus 1, no, it's x squared plus 1. How do we go through this? So here we are going to use the quotient rule. So we let u equal to e to the power x, the derivative of u with respect to x is equal to the same e to the power x. And we take v to be equal to x squared plus 1. The derivative of v with respect to x is equal to 2x. And from the quotient rule, f prime of x, the derivative of f with respect to x is, we differentiate the top one times the down. So the down is x squared plus 1 times e to the power x, that is du dx, the top one, the numerator and the denominator, minus, we maintain the numerator e to the power x times the derivative of the denominator, that is 2x, all divided by the denominator squared. And this will give us e to the power x into bracket. I'm factorizing e to the power x out. So here I'll get x squared plus 1 minus 2x, all divided by x squared plus 1 all squared. And this will give me e to the power x times x squared minus 2x plus 1 all divided by x squared plus 1 all squared as my final answer. So here you see that there's no need to multiply through by this. We have like terms here, so we can factorize it out to simplify the expression. Very simple as that. So let's take the next example. Yeah, if you're enjoying the lesson, please like and then subscribe. Subscribing will not cost you anything. It's just hitting the subscription button. Now let's take h of x is equal to e to the power x cosine of x. So how do we do that? Yeah, that's what I have here. So here we use the product rule. So here h prime of x is equal to, we will maintain cosine of x and then differentiate e to the power x with respect to x plus, we will maintain e to the power x and then differentiate cosine of x with respect to x. So here, if we differentiate e to the power x, we get the same e to the power x. So we have cosine of x times e to the power x plus, if we differentiate cosine, we get negative. So it will be negative e to the power x sine x. So here, you see that if you bring e to the power x in front of the x, it seems you are doing cosine of all these. So here, let's bring the e to the power x to the back. Cosine of x, yes, minus e to the power x sine x. And then we factorize e to the power x out to get cosine of x minus sine x. That's our final answer. Very simple. Let's move on. Now the next question is we have y equal to e to the power 5 minus e to the power t ln of t squared. Now, when I was starting, I said that e is a number. E is a number. And I wrote that it can be approximated to 2.71828. That is to this 5 decimal places. So this e to the power 5 is the same as writing 2.71828 to the power 5. So this is a constant. And the derivative of a constant is what? Is 0. Wow. So let's move with that. So if we are taking the derivative of y with respect to x, if we differentiate a constant, we get 0. So this will go. Now, it has left with this for us to differentiate. So let's put the minus sign here and then take this one. This is e to the power t ln of t squared. Now, how do we do this differentiation? We are going to use the product rule. So for the product rule, we maintain the first one. That is ln t squared times the derivative of e to the power t with respect to t, plus we maintain e to the power t times the derivative of ln of t squared with respect to t. Wow. So if we differentiate e to the power t, we get the same e to the power t. So we are going to get here as e, okay, let me put them here first, e to the power t ln of t squared. And here, what are we going to get? I said, watch the video on derivative of natural logarithmic function. That is ln. So here, if you want to differentiate ln t squared, you take the inner function, that is t squared. You differentiate it and you divide it by the same t squared. So if you differentiate t squared with respect to t, you get 2t. And if you divide it by t squared, you're going to have 2 divided by t. So here, we are going to have this one is to be equal to plus e to the power t times 2 divided by t. I said that if you want to differentiate the natural log ln t squared, you can request for the video on the derivative of this from the comment section or the comment section, and I'll give you the link. Or check the description and then watch the video on the derivative of this. So take this one, t squared, differentiate this with respect to t, get 2t, and divide it by the same t squared, and to give you 2 on t. So that is what we've done here. So here, we are going to have this as e to the power t ln of t squared plus 2e to the power t divided by t. Wow. So we have something common. Yes, we have e to the power t, e to the power t. So this will give us negative e to the power t into brackets ln of t squared minus 2 divided by t. Wow. Very simple as that. Now let's move on to the next question. So these examples that we are solving may not be the exact questions you may get in your exams, but it will improve your understanding. We have y is equal to 5e to the power x divided by 3e to the power 2x plus 1. Now, let's do that. We are going to use the quotient rule. So here, the derivative of y with respect to x will give us, we differentiate the numerator and multiply it by the denominator. So we have 3e to the power 2x plus 1 times the derivative of 5e to the power x with respect to x minus 5e to the power x times the derivative of 3e to the power 2x plus 1 with respect to x. All divided by the denominator squared, that is 3e to the power 2x plus 1 all squared. And here, if we differentiate 5e to the power x, let's see. The derivative of 5e to the power x with respect to s, 5 is a constant, so you bring 5 out. You have d dx e to the power x. So if we differentiate e to the power x, we get the same e to the power x times 5. Will give us 5e to the power x. So we are going to have this one as 5e to the power x times 3e to the power 2x plus 1 minus 5e to the power x times here the derivative of 3e to the power 2x plus 1 with respect to x. So you differentiate it 10 by 10. So this is the same as the derivative of 3e to the power 2x plus the derivative of 1 with respect to x. So here 3 is a constant. So 3 will come here and we have d dx e to the power 2x. If we differentiate 1, you get 0, so we put 0 there. And if you differentiate this, the 2 will come and multiply. So 2 times 3 will give us 6. So you are going to have 6e to the power 2x. Wow. Very simple as that. The derivative of a constant is 0, so it's 0. Now how do we differentiate this? This is the same as 3 times 2e to the power 2x, and 3 times 2 is 6. That is what I've done there. Now let's move on. All divided by 3e to the power 2x plus 1 all squared. And what will this give? Here we have this one there. So you can factorize it out. So you have 5e to the power x times 3e to the power 2x plus 1 minus 6e to the power 2x. All divided by the denominator 3e to the power 2x plus 1 all squared. So here we have 3e to the power 2x minus 6e to the power 2x. So we are going to have 5e to the power x times negative 3e to the power 2x plus 1 all divided by 3e to the power 2x plus 1 squared. Now, let's continue here. Here, if we factorize the negative out, we are going to get negative 5e to the power x times 3e to the power 2x minus 1, all divided by 3e to the power 2x plus 1, all squared. And remember that this one cannot cancel this, because the term at the top here is not the same as the term here. And you can't see that this will cancel this. No. Very simple as that. So this will give our final answer. Or you can leave the final answer here by bringing 1 in front and then sending negative 3 here. It will be the same. Okay. Let's take the next example. The next example, we are going to consider y equal to sine squared e to the power square root of x squared minus 1. Wow. So let's see how we do this one. So here, this is the same as y equal to sine e to the power square root of x squared minus 1, all squared. So here we are going to use the chain rule. So we are going to let u to be equal to the inner function, that is sine into bracket e to the power square root of x squared minus 1. And now this implies that the derivative of u, this implies that y is equal to u squared. Now, what do we do? Let's chase u first. Here, or let's put this implies that y equal to u squared here, so that we can get all these places for the derivative of u. I want to do it step by step so that we get the understanding very well. So here, this one also requires chain rule because it's a function of a function. So we take a equal to the inner function, that is e to the power the square root of x squared minus 1. Now, how do we differentiate this? Now here, this implies that we have u here to be equal to sine a. Wow. How do we differentiate this one too? This one too will require the use of chain rule again. So here, if I let v to be equal to square root of x squared minus 1, this implies that a is equal to e to the power v. Now, this one too will require the use of chain rule again. So let's see. Let's take our time. Here, we are going to take v to be equal to x squared minus 1 to the power half. And then let's differentiate this one. So this one to go to, so here the derivative of v with respect to x will give us, we bring the half here, times, we differentiate the inner one to get 2x, times the original function inside, x squared minus 1. Then you subtract 1 from the top. And this will give us, this will cancel this. We have an x divided by x squared minus 1 to the power half. That is given on dx. So here, the derivative of a with respect to v is the same e to the power v, and that will give us e to the power square root of x squared minus 1. So we found our dv dx and dA dv. So we can find dA on dx, and that will give us dv dx. That is what we have here. X divided by half means square root. Power half means square root. So we take square root of x squared minus 1 times dA dv, that is e to the power square root of x squared minus 1. Wow. And this will give us x e to the power square root of x squared minus 1 divided by square root of x squared minus 1 as our derivative of a with respect to x. So we found derivative of a with respect to x. Let me put it here. We have to find our du, dx, and then we multiply it together. So here, the derivative of u with respect to x is equal to cosine a. Sorry, the derivative of u with respect to a, rather, is equal to cosine a. And that is the same as cosine. What is a? A is this one. So we take cosine e to the power square root of x squared minus 1. Wow, so now I think I can clean this portion. So now we know that du on dx using the chain rule will contain dA on ds. Sorry, dA on ds dot du on dA. So any one of them, we take dA on dx times du on dA. And that will give us x times e to the power, to do it, I have the board, let me do it now. This is the same as x times e to the power square root of x squared minus 1, wow, divided by square root of x squared minus 1 times du dA, that is cosine e to the power square root of x squared minus 1. That is our du dx. Now that we found du dx, we are going to find dy du. So here, the derivative of y with respect to u is equal to 2u, and that is 2 times, what is u? U is a sine into brackets e to the power square root of x squared minus 1. Wow. Very simple as that. So here, the derivative of y with respect to x will be equal to, this is du dx. So we quote du dx, that is du on dx times dy on du. And that will be equal to x times e to the power square root of x squared minus 1 divided by square root of x squared minus 1 times cosine what? E to the power square root of x squared minus 1 times 2 times sine e to the power square root of x squared minus 1. Wow! That you can put all these to the top. Let's put it to the top. We are going to get 2x e to the power square root of x squared minus 1. Then, wow, we are going to have cosine of cosine into bracket e to the power square root of x squared minus 1 sine e to the power square root of x squared minus 1, all divided by square root of x squared minus 1. Now we have something very, very interesting here. Very, very interesting here. Now, if you watch my video on sum angle formulas, we said that if you have sine x plus x, this will give us 2 cosine x sine x. Very simple as that. To give us 2 cosine x sine x. And now, here, if we look at the angle that we've got in here, you see this angle. You see this angle. And we have 2 in front here. Wow. So you can do something with that. You can do something with that here to simplify our answer further. So here, this implies that if I have sine, watch this, e to the power square root of x squared minus 1 plus e to the power square root of x squared minus 1, I'm going to get 2 cosine e to the power square root of x squared minus 1, then sine e to the power square root of x squared minus 1. Wow. So in place of this times the 2 here, we are going to get our final answer as x e to the power square root of x squared minus 1 cosine 2 e to the power square root of x squared minus 1 all divided by square root of x squared minus 1 as the derivative of y with respect to x. Wow! Very, very nice approach to the question and a noble solution. Very simple as that. So if you check the video, you see that this is very, very nice. Very, very nice. Correct. Because if you add this to that, you are going to get 2 of them. Very simple. So watch my video on proof of sum angle formulas or sum angle identities for cosine and sine. You get to understand that better. You can request for that at the comment section, and it is also in the description. You can check that. Wow. So let's move on. Very simple as that. Let's take the next example. Let's take the next example. Now, the next example, we are going to consider y is equal to e to the power negative tangent cube x squared minus 5. Now, how do we differentiate this? Wow, this one is the same as letting u to be equal to the top, the exponent, negative tangent cube x squared minus 5. Very simple as that. Now, this one is the same as negative into brackets tangent x squared minus 5 all to the power 3 as our u. So here we write this implies that y is equal to e to the power u, since we've got the negative here. Now, here the derivative of u with respect to x will be given by, if you want to differentiate this, you go through the chain rule. And for the chain rule, what do? This 3 will come and multiply the original function. So you have minus 3, and the original function is tangent of x squared minus 5. Then you subtract 1 from that to get 2 times. Then you differentiate what is inside here. Now we are going to have tan x squared minus 5. Check the description for the derivative of trigonometric functions. You get to understand this, or you can request for that at the comment section. Now, how do we differentiate this? This also will require the chain rule. So you differentiate the inner function to get 2x times the original function, and the original function is tangent of Okay, let's go through the chain rule small to do this one. Let's take m equal to this. So here what do? We take u equal to s squared minus 5, right? So here du on dx is equal to 2x. Very simple as that. And that we have the tangent, we have m is equal to the tangent of m. And here derivative of m with respect to, so the tangent of u. Derivative of m with respect to u is equal to secant squared u. And that will give us secant squared s squared minus 5. So here, the derivative of m with respect to x will give us 2x times secant squared into bracket s squared minus 5. Wow. So that will give us 2x secant squared s squared minus 5. Very simple as that. So here we are going to multiply this by 2x times secant squared s squared minus 5 as du on dx. And this one will be simplified to minus 6x times tangent of x squared minus 5 all squared, then secant squared x squared minus 5. Okay, let's bring the square here and put this in brackets. Now let this be attached to this secant squared x squared minus 5 as du on dx. Now we have to find dy du. So here the derivative of y with respect to u is equal to the same e to the power u is equal to e to the power negative tangent cube s to the power 5 minus, s squared minus 5. So now you can quote the derivative of y with respect to s to be equal to du ds minus 6x tangent squared s squared minus 5 secant squared s squared minus 5 times e to the power negative tangent cube s squared minus 5. And that will give us negative 6x e to the power negative tangent cube s squared minus 5 times tangent cube s squared minus 5 times tangent squared times secant squared s squared minus 5 as our final answer. Please, this one is mixed derivatives, so check the description for the sequence of videos that will improve your understanding better. Okay, now we've done a lot, but it is not enough. Let's take the last example. The last example is what we are going to do, and the question is y is equal to square root of ln of e to the power 2x minus e to the power negative 2x. Wow. Okay, yeah, plus e to the power negative 2x. Now how do we differentiate this? Let's do that. Very simple. Here we are going to have y equal to ln of e to the power 2x plus e to the power negative 2x all to the power half. Now since we have to the power half, we are going to use the chain rule. So we are going to get u equal to ln e to the power 2x plus e to the power negative 2x. Now this implies that y is equal to u to the power half. Now how do we differentiate this one? We know that to differentiate the ln, we differentiate the inner function and divide it by the same inner function. So the derivative of u with respect to s will be given by d dx e to the power 2x plus e to the power negative 2x divided by e to the power 2x plus e to the power negative 2x. I've been saying that if you don't understand these derivatives, request for the videos on these at the comment section. Very simple. Or you can check the description. I've listed these videos there and watch it for better understanding. And here, the derivative of y with respect to u is equal to half of u to the power negative half. And this will give us 1 divided by 2 square root of u. That's the same as 1 divided by 2 square root of u. And what is u? U is a lane of into bracket e to the power 2x plus e to the power negative 2x. Very simple as that, as our du on dx. Now, sorry, dy on dx. Now here, du on dx is equal to, here we are going to differentiate it term by term. So if you differentiate e to the power 2x, you get 2e to the power 2x. If we differentiate e to the power negative 2x, you get negative 2 e to the power negative 2x, all divided by e to the power 2x plus e to the power negative 2x. Now, we have to find the derivative of y with respect to x. So I think we can write it here. The derivative of y with respect to x will be equal to du on dx times dy on du. So let's do that. This will be given by, this is our du dx, 2 e to the power 2x minus 2 e to the power negative 2x divided by, let me clean this part, divided by e to the power 2x plus e to the power negative 2x times dy du. 1 divided by 2 times square root of natural log of e to the power 2x plus e to the power negative 2x. Wow. A noble question with a noble solution. And we are done. So we multiply 1 by what is at the top to get 2e to the power 2x minus 2e to the power negative 2x, all divided by, okay, we can factorize these 2 out since we have 2 here. So let me bring the 2 out and put this in brackets. All divided by 2 into brackets e to the power 2x plus e to the power negative 2x times the square root of natural log of e to the power 2x plus e to the power negative 2x. Wow. So yeah, these 2 will cancel these 2 and our final answer will be that. So I don't want to repeat it. So the 2 will cancel the 2. I'm cleaning it to go off. And that the brackets here too will go off since the 2 has gone. Remember, this cannot cancel this one. And that is our final solution. We will end up here because I've taught for a long time. Thank you for watching, and please subscribe to my channel, share my videos, and also like them. Bye bye.